Come on up here. Oop, there we go. There's the slide. All right, welcome and good afternoon. I hope you all are enjoying this conference as much as I am. This is my first time at the Women in Analytics Conference, so I'm pretty excited. My name is Lauren McDonald, and before I kick off the official talk, I wanted to introduce Systems Evolution Incorporated, which is the company I work for. We're a small business and technology management consulting company, and we have locations in 10 major US cities. So SEI, we were founded on 4 core beliefs. Experience matters. We hire senior professionals that can really go into a client and partner on a solution to deliver results. Community matters. We build a community in the local market, and we only have a local model, so there's not the travel aspect. And the big statistic I want to mention here is that all of the consultants we hired in SEI Cincinnati last year were women. So we have a really large community of women, both starting out, a lot of young mothers that, I'm a young mother right now too, and women that have been there for 20 years and helped to grow the company and grow the culture and to act as mentors. So I've really loved my experience at SEI. I have a lot of passion about it. So if you're interested in learning more, please reach out to me at any point in the conference. But I'm not talking about SEI during this. I'm talking about one of my most recent projects at SEI, which was at a Fortune 20 grocer headquartered in Cincinnati. I'll let you figure out who that is. So let's begin. We started about 3 years ago building an event streaming platform. And today, this now serves as the major data backbone for a lot of the most critical business processes happening across the enterprise. So in building an event streaming platform, we learned a lot. And there's 5 main lessons that I want to talk about today. And I really hope that, I know that there's a variety of people in the room today. There's possibly students, people more in the data analytics, data science space, possibly some business leaders. I'm hoping that these are lessons that you can take away regardless of what platform you're working with or what technology space. So, number 1, invest in a strong foundation, making sure that the solution is both resilient and scalable so that your users can trust what you're doing. Have an opinion. Be strong about what your opinion is and have the ability to say no when a use case doesn't match what that platform should provide. But when you have these strong opinions about how people should use the platform, make it easier to do the right thing than the wrong thing, and keep it simple. I'll mention users a lot, but cultivating that community and harnessing the expertise out of the user community is a really important aspect that we did. And then evolving the platform. We all know that technology, the only constant in technology is change. So making sure that you're continually evolving and not just adding features, but cleaning up and decommissioning as you go. So to get started, I'm going to take you back 3 years ago when we first kicked off this journey, and we started interviewing some of the users to understand where the problem space was. So I'm going to introduce you to 3 people. The first one is the business leader. She's at the top. So the business leader is the one that's identifying the features that need to be released to get value to the customers, and using data and reporting to figure out whether these features actually met the needs or not. In the bottom right, you have your data consumers. These could be real-time applications that are event-driven and performing actions based on a real-time stream of events, or they could be your data engineers, your data analysts, your data scientists that are trying to use the data. And then on the bottom left, you have your application engineers. These are the team members that are actually developing the solutions. So if everybody works together well, then you make money. And it's all happy. So let's walk through a scenario to see what was actually going on. Step 1. Let's use AI and streaming analytics, and we're going to solve all our problems. I'm sure you may have heard that before. So they go to the data consumers, and the data consumers say, well, where do I find the data? How do I use the data? The data just changed and my report broke, and this is just a data swamp. Not a data lake anymore, it's a data swamp. So they're not happy about this scenario. So the business leader then says, I want this new business feature by Friday to the engineers. And they go, I'm spending all this time maintaining all these individual data integration feeds with everybody that wants my data, and I tried to deploy a new feature, but the change broke something from a downstream consumer, and I had to roll back. So at this point, everybody's a little frustrated. So these are examples of actual interviews we had across a pretty large IT organization, and we really had to take a step back and think about how we were going to start solving them. And the first thing we did, we were really close with the users. We wanted to have a user-centric design, but I would say we went a little bit of a step further, and we actually had user designed. And the first thing we did was invest in this strong foundation. We did this with the application engineers in the room with us. They were whiteboarding on the table how to build an HA system, how we were going to build a central streaming environment to facilitate this event-driven communication. And after these meetings and after these design efforts, we very quickly realized that this was going to become that mission-critical communication backbone for very critical business processes. Think a customer submits an order online, it makes it to the store so they can fulfill the order. Or a truck arrives at a distribution center to unload product. This couldn't go down, and we had to make an investment in that. So we spent probably the first 3 or 4 months of this project investing in that foundation, which was full infrastructure as code automation of the system, continuous integration, continuous deployment pipelines so that we could manage it with health checks and rollback capabilities. And that enabled us to have 0 planned maintenance for this environment. And then also, robust monitoring, robust logging so that we could always see the health of the environment. So there were 2 main benefits for this. The first one was, as platform engineers, we were free. We were free from some of the operational burden of dealing with the system when it was self-healing. At one point, we even jumped into chaos testing, where we were purposefully taking down aspects of the environment to make sure that the platform as a whole remained available for the applications. So that was helpful for the platform engineers, and there were only 3 of us. So by having this efficiency where we didn't have to worry about the operations of the platform was really helpful. But probably the biggest aspect here was that it gained the trust of the user community, and it built a reputation where all of the application teams across the enterprise knew that they could rely on this system for being available and to support some of the critical business processes that were going on. So I mentioned reliability, but the other aspect of a strong foundation was scalability. We had to make sure that it was able to scale to an unknown amount of use cases, an unknown amount of volume. So we hit a pretty unexpected event last year. That was supposed to be more dramatic. There it is. So expect the unexpected. Like I mentioned before, this was a Fortune 20 grocer. And when COVID hit, our demand spiked pretty severely. The left chart is the e-commerce traffic coming in for those that are ordering their groceries online to go pick them up. And the chart on the right is the supply chain environment, trying to make sure that the shelves are stocked in the stores. So this was a stressful time for everybody involved, but it was really important for us that we were able to work with our families and figure out what that meant during lockdown without have to worrying about scaling a system as fast as we could so the company could handle the demand. So we were really proud of the fact that we built it to scale to the unexpected. So we were feeling pretty good at this point. We have a really good foundation. But there was another problem in that first scenario, if you remember, where it wasn't just about how to share the data, but it was more about relying on the quality of the data that was shared and understanding that data could break downstream consumers. So this leads into the next point, which was have an opinion. So we built this system with the idea that it was a domain-centric model, where an application team would be part of a domain, and they would publish events related to that domain. With the quality of the data that was sharing, we wanted these domain owners to come up with exactly what they were going to share. So we did a lot of research. A lot of the application engineers were more familiar with JSON. That's how their APIs would that's the data their APIs would serve. But we did some research, and we didn't think JSON was going to be good enough. So we introduced Avro. Now, when we introduced Avro, the first time we said it in one of the engineering meetings, you'd see the engineers look at you like, And they'd slide over to their computer, and you'd see them Google Avro. A lot of people had never heard of Avro, and that was okay. They were willing to take a risk with it. So I'm assuming that a few people in the audience may have heard of Avro or may not have. So I'm going to this is going to be my one point in this presentation that's going to get a little technical. I am going to explain what Avro is and why it solved our problems. So to start off, Avro is a data serialization format. It encodes your data as binary, and in order to read and write the data, you have to have a schema that defines what that data is. So let's use an example. Let's say that there is an event streaming platform for the conference, and we want to define an event that says this breakout was attended. And within that event that you see on the left, you have your attendee, your breakout name, and the date. And these are the attributes that you're going to send with your event. Now, if you're the engineer and you put this in code, it may look like you see on the right, where you have to set the attendee name, the breakout name, and the date. And if you don't have a required field, your code is not going to compile. So at this point, this is a contract between the producers that this data will match this schema, and the consumers can rely on that. So this is why we like to call this schema-first development. You design your schema first, and your data must match. This was a really core component of our event streaming platform to make sure that we're targeting that data quality problem that we saw in that first example. So there's another aspect of Avro and a problem that we saw earlier, where it wasn't just about the quality of the data, but it was the fact that the data was going to change. And this was a pretty dynamic business, and we knew that the data was going to change, and we had to allow it to change. So Avro supports a concept called schema evolution. It gives you some rules where you can change your schema without risking breaking your downstream consumers. So let's add an attribute called feedback. Let's say we're collecting feedback about the event. And let's say, just for fun, we have an application that's collecting the attendance. Well, the attendance app doesn't care about feedback, so it doesn't have to make any change when this attribute was added. On the flip side, if you have an application that is collecting the feedback, it can go ahead and deploy and start listening, and when the feedback data arrives, it can start processing. So those are two examples of backward compatibility. You're not going to break your existing consumers, and forward compatibility, meaning you're protected for the future changes for the schema. So we're feeling pretty good about this. We've got a good solution for the engineering teams. The producers are happy because they're not going to have to roll back. Consumers have a little bit more reliability on the data. But there was another issue about Avro that we weren't a big fan of. There it is. I think I need to point this way. It's keep it simple. So I added a couple of attributes to that schema you saw on the previous slide, and it quickly becomes pretty big. This is editing manual JSON files. Some of our production events that we see in our environment are well over 3,000 lines of JSON. And if I were going to go to an application engineer and say, manage this really large JSON file and you have to do it, they wouldn't. They'd find a way around it. So we had to invest some time into making this a lot easier to use. So one of our core aspects of the platform was to promote a high developer experience, or a high DevX. You may have heard of user experience. We wanted to promote a high developer experience. We wanted to make it easier for them to do the right thing than to try to do the wrong thing. So we did that with 3 ways with Avro. The first thing is we built a UI so that you could explore and navigate Avro schemas a lot easier. We built in edit capabilities that had built-in standards and schema evolution rules, so it was a lot easier for the engineers to evolve. The second thing we did is we built the concept of a component. So in here, I defined a person component, and I could reuse that schema as the attendee and the speaker. And then we did some code generation as well. So we built some code libraries and posted those so that application teams could just pull those into their applications and interact a lot easier with the Avro data. There was a lot of other aspects we did with high developer experience, and I've heard these in a couple of the other sessions, so it's been a little bit validating. We invested a lot of time in documentation, not only upfront, but continual. So we make sure that they're updated so that teams understand how to onboard to the platform easily. We have quick start projects where the goal is you could download this project and be up and running in 5 minutes. I know personally, I love when I am investigating a new open source technology and they have something like that, and you get that really quick win of, okay, I get how to use this. I think I can get on board. So high developer experience was a really core aspect of what we were trying to build here. But it wasn't the only aspect. And this leads into the next one. So just to take you back, strong foundation, be opinionated about what you are, and more importantly, what you're not, and have that high developer experience. And so this will help the adoption. You'll have more and more users, which leads into cultivating this community. This was such an important part of this platform's success, is that, when we started, and I think I mentioned, there's only 3 platform engineers. There's only 3 of us. So when we started this, we invested a ton of time understanding the technology, building these reference patterns, working one-on-one with the users to make sure that they could onboard. But there's only 3 of us. So as time went on and more users onboarded to the platform, I think right now we have approximately 70 different domains with applications producing, and we have 200 to 300 consuming applications. We can't help them one-on-one, but we encourage the community to help each other. So we stood up a Teams channel, and we asked all of them to submit their support questions to the Teams channel. And in the beginning, a lot of times it was us replying to the different questions, and we would try to reply as fast as possible, because there's nothing worse as a developer to be completely stuck and just waiting for somebody to reply to your question. So we tried to reply really quickly, but as we went on, users began to reply to other users' questions. We're like, yes, free support. It was really great as the platform team. And then it started to be, I'm trying this new idea. What do you guys think? Oh, hey, I'm trying that too. Why don't we meet up and figure out if we can implement this idea together? So by fostering this community and providing a place where they can share these ideas, it was a really cool thing to watch. We even had the scenarios where someone needed to advance a library with a feature that we didn't have time to do. He's like, all right, I'll do it. Added the feature into the library and submitted a pull request. And I'm like, we have an open commit model. Yes, this is great. So the other story I want to add about users, so just the other day, there was a meeting that we had where the application, it's a big initiative, a big business initiative, and they had a problem that was due to a bit of an anti-pattern. So it was something that they didn't like, a little bit of tech debt in the application. But they invited us saying, if you could just do this little change, it would fix our problem until we're able to fix it. Well, we had one of these power users, somebody that understood why we were built, that was in that meeting that said, no, we have to take the responsibility for this. We're not going to burden a central platform team with a Band-Aid because we have an issue in our application team. So we need to take on the tech debt and feel the pain so that we're motivated to change it. And having these stewards and these advocates out in the user community that understand why you were built the way you were was really helpful to the health of the platform. The other aspect of the user community, I could go on and on about the user community, but it gave us a forum to understand what was coming, what technologies they were interested in, what languages they were using, and this leads into the last topic, evolving the platform. So this quote is probably overused. The only constant in change in the technology industry is change. And this is normal, and in the last 3 years, we've had a lot of change, new languages, new technology platforms. Halfway through, the entire enterprise decided to move onto the cloud. So we had to figure out how to help all of the users move to the cloud. The biggest one I want to talk about in this area, though, is not just about adding features. It's about making sure that you're decommissioning and you're celebrating that. You know, it's not that work that you're like, oh, I have to do the tech debt today. But when you do it, it's like, maybe it's cleaning out your closet, and that feels good sometimes. So the story that I have in this one, when we got started, probably only 6 months into the journey, there was a really big initiative going on to ship groceries to a customer directly. And to do that, we needed to accept in data from a partner. So we had to build a REST endpoint where they could publish JSON data to an API, and we were able to persist that in the event streaming platform. We only had like 2 months to do it. So we did some research, we found an open source tool, we deployed it out, we got the partner onboarded, they were fine with it, and we met the business deadlines. And we were celebrating. Everybody was celebrating. It was a huge engineering effort across the board, and everybody was really excited that we were able to pull this off in such a short time period. But I hated this tool so much. It was not scalable. We knew that the volume was not going to meet the needs of the partner going long term, 2 years from now or so. It was not easy to onboard a new partner. So as we wanted to become more open to integrating with different vendors directly, it wasn't going to be easy. And it presented some technical aspects of the system that just weren't ideal to show to a partner. So we released this, we learned a lot, and we decided to build our own. So we built an environment we built a system that we call the ingestion API that was scalable with whatever volume we needed to throw at it. Very easy, as if a partner comes in with a client ID, we could create a client registration. They could really quickly start posting event data to that endpoint. And then we even introduced an extra level of data quality where it wasn't just the schema and structure that they were sending, but you could actually specify rules on this specific attribute level and return an immediate error to that partner saying, we're not accepting this data because it's violating these quality aspects. So it was this real-time feedback with the partner. We onboarded a couple of new partners, some trucking companies, a startup, and they actually loved it because it was a good experience for them to understand how to interact and validate the data that they're sending. But we had an issue. We still had that first partner on that old tool, and we started getting calls in the middle of the night that it wasn't keeping up and dealing with some operational burden, keeping this thing alive. So we finally convinced them to move to the new system when it just was, we were both dealing with some operational issues. And they finally moved, and we pushed the button, and we decommissioned it, and we celebrated. It was a celebration in twofold. It was a celebration that we were able to meet this business objective and deliver a really cool feature for the customers. And it was a celebration that we were cleaning out our closet and we were remaining efficient as engineers. So it was probably I was probably more excited than my other engineers, but it was a good experience. And so those are my 5 attributes. So just to review, step 1, invest in a strong foundation. Make sure that it's resilient and scalable to build a reputation that your users can rely on and that they can serve their mission-critical application use cases for event-driven architectures on this platform. Have an opinion. It's okay to say how people should use that platform, and more importantly, how they should not use that platform, and make sure it stays as efficient as possible. But make it easier to do the right thing than the wrong thing. That's the easiest way to work with application engineers. A lot of times we take our own advice, and if something gets a little hard, it's frustrating. So keeping it easy for the engineering community encourages adoption in the right ways. Cultivate the community. Your users are your best assets. Encourage the advocacy and the influencers out in the community to uplift the platform and figure out where it should go in the future, and help each other out in how to use it. And then finally, evolve the platform. It's always going to change. Make sure you're not only adding those features, but you're also decommissioning as you go. So that's all I have today. So thank you very much for attending. Questions? Yeah.
You're building all these tools, it seems anymore like there's so many options out there for different tools that do similar things. How do you decide what is going to go into your tech stack, and if it's going to meet your objectives, which one is the right one to meet your objectives, and how does that plan forward into your future roadmap?
That's a good question. I think to start with, I like to ask a lot of people, especially if there's people that have experience in some aspects of the technology. It was a really big organization, so we actually used Kafka as the backbone, and we already had Kafka expertise in the enterprise, so it was easy to ask them on what their opinions were. So that's the first step, is do the research, ask around, and then where possible, try it out. How can you identify small little proof of concepts where you can see if that tool is going to meet the needs, and if there's any holes or showstoppers within the technology?
Thank you. Could you elaborate a little bit more on how you use Kafka in the integration?
Yeah. I'll have to. So, are you aware? Do you want me to explain Kafka real fast to everybody? I'm not sure how many people are aware of it. Kafka is an event streaming platform it was released out of LinkedIn. It's the ability to publish large volumes of data and then subscribe in an event streaming way. So you can have multiple consumers on a specific topic, and you can process the data in order along a distributed commit log. Trying not to get too technical into the weeds. What we did is we organized it by domain. So if you think of fulfillment or how a customer's order gets fulfilled in the stores, you may have a domain for item, how you define what a product is. Each of those had their own topic. And the producers could have multiple events per topic, but they owned their topic. And consumers, if you're interested in the product catalog data, you would subscribe to the product catalog topic, and you would receive the events that were related to product. The producers owned the data asset. They were responsible for the schema, and it was very bounded so that you understood what the data was within that topic. that's how we used Kafka on the bottom. It was to support the volume that we needed, since it had a distributed model. But what we added was on top, was along this architectural domain-centric model, and then this schema-first development. Okay. Oh.
One aspect of developing trust with the people in that company would have been to have quality checks, right? So what kind of quality checks did you have for the data coming in and for the data in the topics that people could subscribe to?
That's a good question. So for internal communication, it was just Avro, which is really that first level. It just guaranteed the structure of the data. It didn't, and typing. It was really basic level quality checks. For the partners, our partner ingestion API was written in Go, and there was a library that we used. I can't remember the name, but it would do like 2 regexes. Like you could do a regex to say this attribute needed to match this pattern. To kind of add a little bit. And we could customize that based on the partner. So if we expected certain things from one partner, not from the other, we could customize that. So the question was, did the library already have the checks built in? It gave us the framework to design the checks, so we could check a field with a specific regex, and then we built the system around it to capture what the rules were going to be, and not just the rule, but we also captured what we wanted to display back to that partner. So if they violated that rule, we wanted to say something specific like, truck identifier numbers must begin with 367 or something like that. So we wanted to give a little bit more feedback to the partners we were integrating with.
Development, right?
We use Go to build this ingestion API, yeah. It provided us the scalability that we needed for the volume that we were handling.
Would be great to know the library if you can remember.
I'll look it up. I can't remember. Yeah.
Okay. So in adopting this new platform and this new framework, was your entire team, part of it and excited about it from the ground up, or were there aspects of the company that you had to convince to start working within this new platform? And how did you, kind of enact change and motivate excitement for that change?
Yeah. We were lucky in this specific scenario where sometimes I use the metaphor of we felt like we were the puppy that caught the ice cream truck. There was such a need for this system in the engineering community that once we built it, the floodgates opened. And even teams in the supply chain group that had more of the traditional IT systems, like even mainframes, once they understood the power of, I can produce my data once, I'm in full control, you're going to stop reaching into my database to pull data, and I'm in full control of the data that I'm exposing, and I only have to do it once, I'm in. Tell me how to integrate. So it really started snowballing across the enterprise to support some really unique use cases, and we were all really excited about it, the 2 engineers that I work with, so it was a fun project.
Hello? Okay. Just out of curiosity, how did migration of existing warehouses, databases work in setting up this new platform?
That's a good question. I don't think we set out to replace existing databases or data warehouses. What I think is evolving is that these producers, I keep mentioning domain. So these producers had full control over their domain, and if you wanted to interact with their domain, you could choose the API or the stream, and that was your choice. And anything inside of that that they needed for their database, their data store, that was within their own control, and they didn't have to worry about people interacting with it. On the flip side, there are, I mentioned it in the talk, there's data consumers that are the analysts, the scientists. There were data lakes, there were data warehouses. They were just yet another consumer of the event stream and the data. So they would take data off of the platform and do the modeling that's needed from transactional data to transform it into what a data warehouse was going to expect. Did that answer? No?
Hello? There we go. So I guess the original question was like, so if they didn't already necessarily maybe have access to somebody else's data, that they would now have the ability to pull through the pipeline,
Yes.
right? So is there like an initialization process where like people have the ability to pull data, even like historical data through it? Or am I thinking about this incorrectly maybe?
Are you talking, so if I needed to kind of seed, like if I wanted the product catalog, I don't just want what changed. I need
Exactly.
the full asset. That's a good question. Each use case is going to be a little different, but I'm actually really proud of how we solved this for the product catalog. So think of all items that are sold across the enterprise. We use, in Kafka, there's a retention policy called compaction, which kind of operates like a key value store. So it only maintains the latest version of every key. So we publish the entire product catalog to this topic, and then we publish the changes. And so if you are interested in the entire product catalog, you start at the beginning of the topic and you read through, and then you keep consuming for updates. So that was kind of our way to share that full data asset and then subscribe to changes. Did that answer? Okay. Good. Mm-hmm.
Doesn't Kafka inherently keep it only for like 7 days or something?
It's
The data-
configurable.
Oh, okay.
So there's 3 retention policies. You can do it by time, and you can set that for what you want. You can do it by space,
Okay.
and those you can actually use together, and whichever one hits first. But then there's one on its own, which is compaction. And so that one is just purely that latest key. So it's a bit of an operational challenge, as we've had to watch those topics to make sure they don't accidentally blow up too big. But the benefits outweigh the risks.
Okay. Thank you.
Yeah. Well, I think that was it. Unless there's any other questions. Oh, thanks. Thank you.